Hello and welcome to this section in further maths. But before we continue, our topic for today is binomial distribution. But before we proceed, I would like us to do a quick review of our previous lesson. Okay, welcome back. Now, when you talk of a probability distribution, now, when you're talking about probability distribution, it deals with a theoretical probability model based on the randomness of certain natural occurrence. The binomial and Poisson distribution are discrete distributions. Now, what it's trying to tell us now is that probability distribution tells us about distributions that we can actually use in evaluating any form of occurrence that is not certain. For example, if we're being told like the binomial distribution is one of them, the Poisson distribution is also a member of that. The normal distribution is there. The z-score can also be analyzed as a probability distribution. Now, this arises from a repeated random experiment which has two possible outcomes. So the binomial distribution only works if the outcome of the probability of discourse has only two outcomes, either a yes or a no. Then this is when it comes into play. Or the probability of death and life. That's where the binomial distribution comes to play. So the two possible outcomes of random experiment are usually called success and failure. Just like what I said, death, that's failure, and life, which is success. That is how it is. So since the two events are complementary, hence P plus Q equals to 1, or P is equals to 1 minus Q, or Q equals to minus 1. So what it's trying to tell us that if you add the probability of death and the probability of life, it should be equal to 1. That is one of the assumptions of the binomial distribution. So the probability of success or failure of an event is the same for each trias and does not influence the probability of success or failure of another trial of the same event. So the binomial distribution can be stated thus. So this is a formula for binomial distribution. That is n combination r, the probability of success over number of trials times the probability of failure over number of sample or total sample space minus number of trial. So this is the formula for binomial distribution for combination. So this binomial distribution is suitable when the number of trials is not too large. So when the number of trials is not too large, like if the number of trials is up to 300, 500, then we usually have problem with this. But if it is not too large, then it is suitable for us to apply the binomial distribution. Now let's go into solving some questions that will help us in working with the binomial distribution. Now the question is, it is known that 2 out of every 5 cigarette smokers in a village have cancer of the lungs. Find the probability that out of a random sample of 8 smokers from the village, 5 will have cancer of the lungs. Out of how many? 5 will have cancer of the lungs. So with this, let's start picking our terms that is needed. So probability of those that will have cancer, probability is equal to 2 over 5, because they say that's the value of our P. They said 2 over 5 in the village has it, as in it is known that 2 out of every 5 cigarette smokers in a village. So this is it. That's number 1. What's the value of our N? Out of how many trials? Find that out of a random sample of 8 smokers. So an N is 8 smokers from the village, 5 will have. So our value of R is equal to 5. Remember that the binomial probability distribution is written as N combination R, P raised to the power R, then Q raised to power n minus r. So we have to apply everything here. So with this, we can now solve our P when x is equal to 5, which is simply 8 combination 5. Our P here is what? 2 over 5. But before we solve, what is our Q? Remember that Q is equal to 1 minus P. So therefore, is equal to 1 minus 2 over 5. You have your LCM here. 5 minus 2, which is 3 over 5. So our value for Q is 3 all over 5. So this raised to power 5, which is our value for R. Then our Q, which is 3 over 5 raised to the power, we have it 8 minus 5. So this is equivalent to 8 factorial. Now we are expanding the combination all over 5 minus 8 minus 5 factorial, then 5 factorial times 2 over 5 raised to the power 5 times 3 over 5 raised to the power 8 minus 5 is 3. So our answer now is 56 times 32 over 3125 times 27 over 5 square is 125. So our final value is now 48384. Divide by this times this will give you 390625. So the final probability is 0.124. So our probability that out of the 8 smokers from a village, 5 will have cancer, the probability is equal to 0.125. So with this, I would like to say a very big thank you for being part of this lesson. But in order for you to check your level of understanding on the binomial distribution, do well to take the test that will be appearing shortly on your screen, and always make sure to consult this platform for relevant information on the subject we just finished. Thank you and see you in our next lesson.